Hello students, in today's session of electromagnetic induction, very basics of self-inductance and inductor will be cleared. In this session, the topics discussed will be what is inductance, what is inductance, effect of current in inductor, means if di by dt equal to 0, greater than 0, less than 0, what is the effect? KVL, Kirchhoff voltage law in inductor, and self-inductance of a solenoid. All these topics will be discussed one by one through illustrations. It is requested go through the complete session. It is going to be very interesting. I would also like to request कि अगर अभी तक आपने YouTube चैनल सेट सब्सक्राइब नहीं किया, प्लीज सब्सक्राइब it and share with your colleagues and friends. Now let's start with the question and concepts. Concept regarding self-inductance and inductor. Inductor. Suppose a circuit includes a coil of N turns of wire and it carries current I. The total flux with the coil is directly proportional to the given current in the coil, that is N phi proportional to I. If we remove the constant of proportionality N phi, constant of proportionality comes out to be inductance. This is known as a self-inductance. Self-inductance, SI unit is Henry, and it depends on geometrical parameters, and number of turns in the coil, right? Or another definition, if a current I is passed in a circuit and it is changed with the rate di by dt, the induced EMF in the circuit directly proportional rate of change of current, that is E proportional to di by dt. If we remove the constant of proportionality, that is equal to minus L di by dt, where L is the self-inductance and negative sign is reflection of Lenz's law, that is opposes the cause. Now, potential difference across an inductor. When current is constant, when current is di by dt is 0, means EMF induced will be 0, VA equal to 0, that is VA minus VB will be equal to 0, that is VA equal to VB. If rate of change of current is 0, both will be at the same potential. When current is increasing, di by dt VA will be greater than 0, that is VA minus VB will be greater than 0, that is VA will be greater than VB. When current is decreasing, VA B equal to VA minus VB will be negative, means VA is less than VB, means VB will be greater at potential at that point. The circuit behavior of inductor is quite different from the resistor. It opposes the rate of change of current, whereas it opposes the current. In this case, it opposes the change of current, it only opposes the current. In another session, current left is summation IR equal to summation E. Sign convention, leaving point of the term is assigned the sign. In this case, this will be leaving, current is flowing in this direction. So E will be equal to, say this is E, will be equal to IR plus L di by dt. This is the EF drop across the, put di by dt along with sign. If it is positive, put positive sign. It is negative, negative sign. Inductance of S, inductance of L equal to N square A upon L. That is N mu naught N square A upon L. Self-inductance, it means L is proportional to square of the number of turns, inductive proportional to area of the coil, inversely proportional to length of the coil. This is the dependency, where in case of resistance R proportional to L upon R. That is R equal to rho L upon A upon A, right? These are dependency. Energy stored in an inductor, half Li square. In combination of inductors can be connected in series, can be connected in parallel. In series, Ls equal to L1 plus L2 as that in the resistors. 1 over Lp equal to 1 over L1 plus 1 over L2. Right? Now start with the questions. Question is, the inductor shown in the figure has 0.54 Henry. 0.54 Henry carries a current in the direction shown, that is decreasing in the direction of at a uniform rate minus 0.03 ampere per second. To find the self-induced EMF, which end of the vector A or B is at higher potential? Concept applicable. You know, EMF induced equal to L di by dt. Every parameter is given to you, 0.54 into 0.03. 03. You are considering magnitude only. This comes out to be 1.62 into 10 to the power minus 2 volt. Right? 1.62 into 10 to the power minus 2 volt. Which end of the A is a higher potential? Now current is passing from which point to which point? From B to A. So VB minus VA equal to L di by dt. 0.54 into minus 0.03. That is minus 1.62 into 10 to the power minus 2 volt. This is equal to VVA. Now, as VVA is less than 0, that is negative. Therefore, A point is at higher potential than point B. इस क्वेश्चन में क्या करते हैं, करंट इज पासिंग फ्रॉम दिस पॉइंट टू दिस, तो VB माइनस VA ले लिया हमने, इक्वल टू L di by dt. Put the sign di by dt along with the sign. If it comes out to positive, it is at the higher potential. If it comes out to be negative, then it is at the higher potential. Right? Next question. Before start of the next question, I would like to say that in earlier session on EMI, we have discussed these topics which you can review on statistic learn. I would also like to say that these concept killing videos you can review on statistic learn and the detailed solution of these papers along with the additional information available on statisticlearn.com. You visit there and have free downloading. Now, let's start with the question. Question is, in the circuit diagram shown in the figure, this is the figure. Resistance 10 ohm, inductance 5 Henry, applied this is E 20 volt, I 2 ampere, and decreasing at a rate of minus 1.0 ampere per second. We have to find VAB in this case. Concept applicable solution. KVL is summation I into R plus summation L di by dt equal to summation E. साइन कन्वेंशन क्या होता है? लिविंग पॉइंट ऑफ द टर्मिनल. लिविंग पॉइंट ऑफ द टर्मिनल of battery is assigned to EMF source. Right? This has already been discussed in current electricity in detail, Kirchhoff's voltage. Right? Now in this case, R is given to you 10 ohm. 10 ohm, 5 Henry, E is 20 volt, I is 2 ampere. 2 ampere. We have to find VAB. Now in this case, current is passing from this to this. So I into R plus L di by dt will be passing from this to VAB minus E minus 20. This is 20 volt. Then IR. I is 2 ampere. 2 into 10 plus 5 into di by dt. Di by dt is given to you minus 1.0 ampere per second. Minus 1 equal to VAB minus 20. So 20 minus 5 equal to VAB minus 20. So 15 equal to VAB minus 20. VAB equal to 35 volt. Means this is the answer. Another method is also there that will be discussed in another session. Right? Next question. Question is, calculate the inductance of an air-cooled solenoid containing 300 turns. If the length of the solenoid is 25 cm and zero cross-section is 4 cm square. B part, calculate the self-induced with the solenoid if the current through it is decreasing at a rate of 50 ampere per second. Concept applicable in solution. Self-inductance of a coil is given by mu naught n square A by L. Given हमें चेक कीजिए. फ्री स्पेस mu naught की वैल्यू है 4 pi into 10 to the minus 7 SI unit. Right. 300 times n equal to 300. A and Lenz. A is given to 4 centimeter square. 4 into 10 to the minus 4 meters square. Length is 25 into 10 to the minus 2 meter. using SI units. Substituting in the formula, we get L equal to 1.8 into 10 to the power minus 4 Henry. We get the self-inductance, this is direct formula based question. And EMF B part, minus L di by dt, that is minus L. L is given to you 1.8 10 to the power minus 4 into minus di by dt is given to you 50. This comes out to be 9 millivolt. That is the answer. On simplify 18 5 90 एक है इससे clear. This comes out to be 9 millivolt. Right? Now I would like to request, if you are new to my YouTube channel SETI Shift Learn, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you.